P of x is equal to 3 minus 1 half x. Q of x is equal to x squared minus 10x minus 20. Part A, solve the equation Q of x is equal to 0, giving our answers in exact form. So this is not going to factorise, but I can complete the square. So x minus 5 all squared minus the 25 minus the 20 is equal to 0. So x minus 5 all squared minus 45 is equal to 0. I'm then going to add the 45 to both sides. I'm going to square root both sides. The square root of 45 is the same thing as, I can split that 45 into 9 times 5. The square root of 9 is 3. The square root of 5 is root 5, so that's going to be 3 root 5. Add the 5 to both sides, and I get 5 plus or minus 3 root 5. So that's my answer to part A. Part B, we have to sketch the graphs of y equals p of x and y equals q of x on the same set of axes, labelling all the points where the curves intersect on the coordinate axes. So let me draw the quadratic first, the q of x first. I can see it's got a y-intercept of minus 20. So minus 20 is down there somewhere. The two intercepts we just found on the x-axis were 5 plus 5 roots 3, which I'm going to put over here somewhere. That's 5 plus 3 root 5. And 5 minus 3 root 5. It's going to be down here somewhere. So the quadratic is going to look something like this. That's q of x. Let me draw p of x. That's a straight line. It's got a y-intercept of 3. So I put p here. I put the 3 there. It's got a gradient of minus 1 half. So that means it's going to be going down here like this. I do need to mark on where it intercepts on the x-axis there, so let's find that point. That's going to be when this equation equals 0, where the y-coordinate is 0. So 3 equals 1 half x, just adding the half x to both sides, times both sides by 2, so x is 6 at that point. And there we go, I've drawn both of those graphs. I've drawn p of x in green, intercepting the y-axis at 3 and the x-axis at 6. And I've drawn q of x in blue, intersecting the y-axis at minus 20 and the x-axis at 5 plus root 3 and 5 minus root 3. Part C, use an algebraic method to find the coordinates of any points of intersections of the graphs. So we want the coordinates here and here. So I'm thinking simultaneous equations. When does p of x equal q of x? So that's x squared minus 10x minus 20 equals 3 minus 1 half x. So we will add the half x to both sides. Minus 9 So minus 10x plus 1/2 x is minus 9.5 x, or minus 19 over 2x. The minus 20 minus the 3 is minus 23. I don't like that half there, so let's times through by 2 to get rid of that. And I'm thinking about whether that's going to factorise. I don't think it is, so I could use the quadratic formula here. Which gives me 23 over 2, or minus 2. Okay, so it would have factorised. Anyway, the point is we've got the two x coordinates. The coordinate here is minus 2 something. The coordinate over here is 23 over 2 something. We need to take those and substitute them back into either of the equations to work out the y coordinate. I think it's easier to substitute them into the linear equation here. So first the minus 2, if I substituted minus 2 into that, I'd get 3 minus 1/2 times minus 2. So that's 3 plus 1 is 4, so the y coordinate there is 4. Then if we do the same thing with the 23 over 2, so 3 minus 1/2 times 23 over 2. We'll get minus 11 over 4. So that's the y coordinate there. So that is part C done. Moving on to part D. Write down using set notation the set of values of x for which p of x is less than q of x. So where is p? Where is the green line? Less. So below q, below the q line. Well, over here, the green is below the blue. Remember that blue is going to keep on getting up and up and up. And down here, again, the green is below the blue. So, describing the x values here, that's where x is less than minus 2. And over here, the x values have to be greater than 23 over 2. But I did need to write this in set notation. So this part here, this is the set, so curly brackets like that, the set of values of x such that x is less than minus 2. Or it could have been the set of values of x such that x is greater than 23 over 2. And then that set describes that. So this is my answer here to part D.